Good evening, everyone. I'm Janet Broff, Senior Development Officer at the Georgian Bay Land Trust, and welcome to the third season of our LandMark Speaker Series. Today, our guest speaker is Bill Lougheed, who will chat to us about the impact of conservation on carbon storage. But before I turn it over to Bill, I wanted to take a moment to thank you for your commitment to conservation this past year. Here's how all of you have made a difference in 2021. You helped to protect 3 new conservation properties on Georgian Bay, each in Wawatasi, Cognisheen, and Manitou, which amounts to over just 6 acres, which secures habitat for species at risk and places for people to connect with nature. So now the total number of properties protected by the GBLT is 67, and we're quite excited to let you know that there are 3 more in the pipeline currently. You also supported a new research partnership with scientists from Western University who were in residence this past summer to study songbird behavior. Plus, we added 5 new Motus towers, providing more research and insight to how we protect species in decline. You also helped to steward over 75 acres of Georgian Bay wilderness through a network of over 1,300 amazing volunteers. So a huge shout out to all of you who might be with us tonight who helped volunteer, and we could not have done any of this without you. And finally, you played a role in the GBLT's leadership position in a collaborative natural conservation plan. It was GIS mapping, which shows connectivity between habitats, mapping corridors for species movement, and looking at factors for promoting climate change resilience. So in 2022, our plan is to continue to accelerate the creation of new wilderness areas. And with your help and the opportunity for matching funds from the Canada Nature Fund, we are on track to reach Canada's biodiversity target of conserving 30% of Canada's lands and inland waters by 2030. Together, we all can make a difference. So we ask you tonight to please consider adding the Georgian Bay Land Trust on your charitable giving list this year. Your support will help to grow our important conservation work now and forever. So it is now my great pleasure to introduce you to Bill Lougheed, the Executive Director of the Georgian Bay Land Trust. Bill shares a lifelong love and appreciation for Georgian Bay. He is a longtime volunteer and leader within the Go Home Bay community, a scientist at heart and by training. Bill's career has positioned him in leadership roles in the biomedical industry before finding a home at the GBLT. Bill has grown the Georgian Bay Land Trust in all capacities the last 8 years, and continues to find new and innovative ways for future success. So thank you for joining us tonight. And now I pass it over to you, Bill.
Well, thanks, Janet. You find me actually at Go Home Bay this evening. It's kind of nice up here. It's -12 and 3 feet of ice on the cottage shore. So that's a bit of background information as to what the picture you're seeing right at the moment. So I'm just going to try and share my screen here. 1 second. Okay. So Janet, can you see that? Okay.
Yes.
Okay, thank you. So today's talk, although it's about carbon storage in our area that most of you probably have a residence in or cottage in, I want to draw your attention to some forgotten lands. And what do I mean by that? And why am I talking about forgotten lands? I'm talking about them because they're the lands in your backyard, all the way from your backyard on the coast to the highway. That's sort of GBLT's natural area from north of the French River all the way down to Port Severn. And so those backlands are part of our natural area that we are, as Land Trust, commissioned to protect. So slide shows that area right here, from Port Severn in the south to the French River in the north. And we don't see these because most of us anyway, because we don't walk them. I've walked some of them, but I don't think there are very few people who have walked all of these lands from the coast into the highway. So we don't see them. They're out of sight, out of mind. But if you were to walk back in there, you would see they're literally covered with wetlands. That's what's shown in green here. They're bogs, fens, marshes, open water wetlands, and swamps, and some unclassified wetlands that nobody has gotten to and classified. And this slide shows the connectivity between these wetlands. Just zooming in a little bit more, you can see these wetland structures. These are the kidneys of our landscape. They filter our water, they remove pollutants, and they purify all the water that is exiting from these kidney structures into Georgian Bay. So they are by far, in the Middle Great Lakes, they are by far the biggest purification of the water that enters our Middle Great Lakes. So just a little bit about wetland functions, because I'm going to be talking about wetland functions and carbon storage. They're far more than just carbon storage, as most of you know. They're habitat, nesting and spawning, rearing and resting sites for land and aquatic species, including all of our 6 at-risk turtles, many of our at-risk snakes overwinter there or use these habitats for hunting. They are critical for food chain production for all our species on the coast. In terms of the hydrology, the protection of other areas from erosion, the storage areas for storm flood water, groundwater, aquifer recharge, surface water aquifer recharge, and as I said, water quality protection, water filtration, and water purification. So again, that's how this all happens back in your backyard. We also have extensive forests in our natural area, and it's shown in green here. The lighter areas here, the white areas, are less dense forests. The dark areas are more densely packed forest or old growth forest areas. They too are extremely important for carbon storage, and we'll get into that in more detail as further into the talk. So just a preamble to what a slide that I will conclude with. I'm sorry, I'm going to have to move something out of the way here that's for me. The areas of our forests are 271,000 acres. I'm going to talk in acres because I think a good part of this audience is still thinking in acres, maybe not. You can correct me if I'm wrong with that in the end. Total wetlands, 112,200 inland wetlands. This is all inland wetland areas. And so our inland wetland areas are 26% of the land area of our natural area from the coast into the highway. And our forests are 65%, or denser forests and old growth forests are 65% of that land area. And I'll get into these numbers later on at the top. For some reason, my scrolling, oh, there we go, just a minute. Maybe just a little bit of a recap. This is work by Dr. Muma of Tufts University. It's his slide showing sort of the net carbon fluxes worldwide. And what I want to draw your attention to, because I'm going to be talking about soil and peat in this talk, soil is, the storage of soil worldwide is 2,300 gigatons of carbon. That's what's sitting in the soils worldwide. In terms of fluxes, in terms of photosynthesis is bringing in 120 gigatons of carbon per year and pumping it mostly into the soil. Microbial respiration is taking some of that back out, as you can see to the right of there. In terms of fossil fuels and what we're burning and putting into the atmosphere, that's about 9 gigatons carbon per year. And of course, the oceans are a major net uptake of carbon, with 2 gigatons carbon uptake net per year. But it's really this net terrestrial uptake of 3 gigatons per year that I'm going to be talking about. So wetlands, most of you probably know this, but for those who don't, wetlands are wet lands. They're areas that are saturated or flooded with water, either permanently or seasonally. Inland wetlands include marshes, bogs, fens, swamps, and vernal pools. And the water table can be above or below the surface. So you can see water in a wetland, or you may not see water in a wetland. Fens are made by peat accumulation, may be dominated by sedge, reed, shrub, or forest. And fens are mostly fed by surface streams, lakes, or groundwater. So they have an influx from the peripheries. Bogs are made by peat accumulation, usually dominated by mosses. Bogs appear where the water at the ground surface is acidic, and bogs are predominantly fed only by rainwater or snowmelt. Swamps are wetlands dominated by trees and shrubs, over particularly 30% cover woody species, with wood-rich peat or mineral soils, and water tables typically at or below the surface. They depend on nutrient-rich groundwater derived from mineral soils. And marshes, which probably a lot of you are more familiar because of our coastal marshes, which I'm not talking about in this talk. I'm talking about inland marshes, because there are substantial inland marshes, but this vista probably you've seen in your local bay, or if it's this large, down around Honey Harbor area, Port Severn areas, Wabashin, you see these larger type of coastal marshes. And this is just a very dumbed down slide of in terms of peat formed by partial decay of plant bodies. You basically have your photosynthesis and then decay of the carbon-rich plant material settling to the bottom, partial decay, further partial decay. But once it's down in this gray anaerobic zone, there's no more methane. The decay is very, very slow, and very little methane release after it's down in the anaerobic zone. So that's why you have a net carbon storage pump through this plant material in wetlands. The aerobic zone is basically the blanket that causes the anaerobic zone, simply because gases, oxygen and carbon dioxide, they do not diffuse very well through this, and therefore this becomes a zone that only anaerobic species can survive in. Sorry, I can't see the entire slide here, so I need to move something here on you. Wetlands are among our best systems for long-term sustainable carbon sequestration on the planet. And this includes created and restored wetlands, which I'm going to talk a little bit about. Nevertheless, many climate change scientists review wetlands as sources of greenhouse gases and little else. Now that has changed around in the last several years. The IPCC and other bodies have realized and included in their models green wetlands, and so they have now been recognized. But 10 years ago, they really weren't recognized that well in terms of their ability, in terms of helping out climate change. So we've lost 60 to 80% of the world's wetlands, depending on what source you go to. But most wetlands are carbon sinks. Their role in emitting methane gases is less consequential because methane decays in the atmosphere while CO2 does not, and their life cycles are drastically different, with methane life cycle being much, much shorter than carbon dioxide. So here are some of the other quotes on our wetland loss in the last 20th century. Russi et al. 50% lost. The ISPPC BS S 87% of the world's wetlands have been lost. But the rates, regardless of what the actual number is, it's high. It's at least over 60%. Regardless of all that, the rates of loss are greatest for inland wetlands. I'm having trouble changing my slides here. So when we talk about wetlands in terms of ecosystems, they're the most productive ecosystems in the world. The average net productivity is 1,180 grams of carbon per square meter. And the surface area is 9 million square kilometers worldwide. They are the largest pools of stored carbon on Earth, according to Swaran study in 1993. So while wetlands cover only 6% of Earth's lands, but they store 20% of its carbon. And since 1970 alone, we've lost 35% of those. How we lost that? We've lost it by drainage, mainly by drainage or infill for agriculture. It's also, I should also add development on that. So Canada, we may think of our country as being somewhat perfect in terms of its natural habitats. This is showing up here, the loss of habitat in Canada from 1800 to 2006. So we don't escape these figures. And when we look at Ontario, here is the good news. And this is what this talk is primarily directed at. North of this line below here, 80% of our forests remain, 90% of our wetlands remain. We have 50 species at risk. Even though they're at risk, most of their populations in terms of viability are in the good to excellent range. So yes, they're listed, but they're listed mainly because of what the stress is on them in other areas of our province. When we look below this line, 80% of Southern Ontario's wetlands are lost, 70% of its forests have been lost, and there are 200 species at risk. So when we look at wetlands and we sort of think, well, we can sort of get away with somewhat disturbing them, putting a huge development right next to them, which affects the influx of water to them. It changes, it allows them to flood and then drain, et cetera, rapidly. This is sort of looking at the carbon storage ability in reference wetlands and looking at them, what happens to them when they're disturbed. And even minor disturbances shown in this slide can reduce carbon sequestration by 50% to 150 or 200%. Now this slide is looking at fluxes in pentagrams per year of carbon. This is again worldwide. This is our fossil fuel flux into the system. But when we look at wetlands, the carbon sequestration worldwide by wetlands is one part in that 10 of those fluxes. So it's a very, very significant part. Forests play into this as well, and the ocean does as well. So that sort of gives you a sort of over 30,000 view of the importance of wetlands in terms of carbon flux out of the atmosphere and carbon flux into the atmosphere. Now, methane's gotten a bad name. It certainly is scared many people, but when we look at fluxes in wetlands, this is a study from Ohio, from Mitch et al. In 2014. If we look at a newly created wetland, which they did outside of their university in Ohio, and they looked at methane emissions over the time course of out to 60 years, I think it is now. Maybe it's 40 years, I've forgotten. In newly formed wetlands, the methane emissions do increase, but then they flatten, they go asymptotic. Whereas the carbon sequestration of these newly formed wetlands, they just increase with time. So this will eventually flatten out, but a really rigorous wetland is going to flatten out at 400 or 450, way up here. So that just shows you, this is a tool that can be used, and I'll touch on it later on in the talk, in terms of solving our carbon problems. This slide I've placed here because it shows you, if you have flooding, if you put a development or some other big hardened area next to a wetland and you allow flooding of it, and as the water table rushes up drastically over a short period of time, methane is released. Once the water gets to a higher level, then the methane release goes down again. That's because the anaerobic, aerobic business, the water interferes with it, I touched on earlier. So if you look at a flood of a wetland, what shows in terms of days after it being flooded, on the horizontal axis here, you see the methane being released, and then it subsiding back down. So, if you don't protect that whole kidney structure and allow the flooding to spread out over a vast sort of kidney array, you're going to get this kind of symptomology happening, and methane released, and therefore carbon dioxide released, or methane released in the atmosphere turning into carbon dioxide. So why am I talking about wetlands and the peat they produce? Mainly because these dark green areas here in northern parts of the northern hemisphere, they're a big part of our carbon storage, and they're a big part of our solution of climate change. And they extend right down into our area on Georgian Bay. So peatlands, while they only cover about 3% of our planet's land, they account for nearly half of the world's wetlands. That's from the IUCN in 2021. Peatlands above 45 degrees north, which we are in our natural area, store up to 300 kilograms of carbon per meter squared. That is 10 to 20 times more than tropical rainforests. It's 90% of peatlands exist north of 45 degrees latitude. And in total, they store 400 to 600 gigatons of carbon. That's what's in store now. That's about 1/3 of the world's carbon stores. So why is that important? So this is what's called a relative forcing diagram. And what I want you to pay attention to is this blue line here. And this is basically what wetlands are doing for us in terms of sucking up carbon that would otherwise go into the atmosphere. So if you look at this point down here, that is 74.2 petagrams, or billion tons of carbon removal by wetlands. That is absolutely huge. So if this weren't happening, then that would be all released up, and this curve would be going up, and our CO2 would be going crazy in the world. So, and that in terms of just heating, you can see that's intercepting this axis here at about 0.4 watts per meter. That doesn't sound big, but that in terms of slowly raising our temperature of Mother Earth, that is a very significant radiative forcing. So maybe this perhaps will help you visualize it better. This is just let me get this out of the way. This is work by Dr. Nigel Roulet in 2018, and the red banding here shows the decrease in carbon dioxide and other greenhouse gases that is resulting from our world's wetlands. So imagine this red line here, if it weren't there, everything to the right of there, all those gases would be increased by that amount. So that probably visually is probably one of the best slides I can show you in terms of what peatland cooling effect is. So just touching on, conservancies and what they do, and in terms of our role is in this brown or tan area right in here, land use change. So this is the increase in CO2 flux, carbon dioxide flux into our atmosphere due to land use change, whether it doesn't matter whether it's agriculture, urban development, what have you. It's any change, infill of a wetland, et cetera. It's all included in this area. And that shows how significant land use changes even compared to our fossil fuel industry, which I might add, really this took off after World War II in 1945. That's where this inflection point is. And this again shows the land sink down here. So just keep that, this slide in mind as I go forward on the rest of this talk. Because land use change, this is something we can influence going forward. Well, Ontario wetlands contain approximately 29, or moving on to Ontario now. Ontario's wetlands contain approximately 29 gigatons of carbon, which represents about 19% of Canada's wetland carbon and 6.6% of the global total. The largest proportion of wetland carbon occurs in fens and bogs. In Ontario, wetland sequestration rate is about 10.6 megatons carbon per year, with a back release of 4.3 million tons of carbon per year, with a net of sequestration of 6.3 megatons carbon per year that's stored every year. So just on a side slide, in terms of what we can do about all of this, restoring grasslands to wet condition worldwide would contribute a reduction of 2 gigatons of carbon per year, and preventing losses from wetlands and wetland soils 1.5 to 2 gigatons of carbon per year. It's from Bill Mua of Tufts University. So if we look at just our ecosystem, our natural area. So this is the Georgian Bay biosphere area that I'm talking about here. And this is the carbon sequestration rate in tons of carbon per year by each type of wetland or by forest. So our total sequestration rate on our natural area from Port Severn to north of the French is 130,000 some odd tons of carbon per year. And the total carbon held by those wetlands is 137 megatons of carbon. And our forests are sequestering about 135,000 tons of carbon per year. And the total carbon stored there is 164 million tons. So when you look at these totals of 301 tons of carbon stored in our natural area in the biosphere, and 265,750 tons of carbon per year sequestered. So you look at what does that mean? Well, the megatons of carbon per year, the total estimated carbon stored in our wetlands, that's equivalent to 75 million cars operating for a year. That's the carbon dioxide output of 75 million cars. In terms of yearly storage, it equates to 70,000 cars. So it's a really significant amount of carbon that's stored by our forests and wetlands in our natural area, which includes the Georgian Bay Biosphere Reserve. So I want to just touch on, I'm happy to take questions, and we can go back over some of these slides. Some of them I think are kind of complicated, but kind of interesting, I think, anyway. I want to just touch on kind of Nature Smart Climate Solutions Fund. And our land trust has submitted a proposal with respect to that. We've also submitted a proposal to the Ontario government that is similar. And these proposals are to preserve our inland wetlands in their present condition or close to the present condition. And this is a matching fund, and your dollars donated to us will be matched by the fund's dollars if our application is successful. And again, this is to preserve our inland wetlands and the forest buffered areas around these wetlands. So this is sort of just a call to help us preserve our inland wetlands now that you know how important they are. And I'll be talking more about this exciting campaign that we'll be launching this spring. And so you'll hear lots more about that. So thank you for attending and listening. And over back to you, Janet or Sarah, whoever's taking over the helm here.
All right, thanks, Bill. So yeah, if anyone has questions for Bill, please go ahead and type them in the chat box and I will read those out. We have one question that came in here during the presentation wondering, does this mean no more peaty Scotch? And what else can we do? Can we lobby governments?
Well, good question about the peaty Scotch. I don't think that's really the amount of Scotch drunk in the world would even touch the kind of figures that I'm talking about. So yeah, I wouldn't worry about their Scotch supply. Sorry, what was the second part of the question?
What else can we do? Can we lobby governments?
Yes, certainly one can lobby governments. That's really important. And you know, this information, you're welcome to use it to help lobby governments and let them know. I mean, part of lobbying is education. Definitely there, you know, the lack of knowledge of the importance that I presented here tonight. I think if more people had this more fine-grained understanding of how important and how our area is compared to others, with 26% of its land mass being upland wetlands, and their importance in carbon change, I think that would turn some political heads. So,
okay. Dale is wondering if our NSCS fund application is focused on acquisition.
yes, it is.
Okay. And Nicholas says, I would love to know more about the methodology or methodologies used to estimate the greenhouse gas sequestered by different wetland types and forests.
So those methodologies are, sorry, I've lost my screen here for some reason. Those methodologies were drawn from a number of peer-reviewed papers. So I was using, these are not, these are, you know, taking averages from peer-reviewed papers of what different types of wetlands in Ontario store and can store. And so this was Ontario specific. Some of the other figures quoted elsewhere are worldwide figures, and they're not mine, but the slide that is mine is derived from peer-reviewed scientific articles.
And do you have any idea how the authors of those articles determine the numbers?
Yes, they determine them from core sampling and measuring carbon in different types of wetlands.
Okay. Janet's
And
wondering,
measuring the depths, of course, averaging depths of wetlands in different areas. And those assumptions, of course, there were assumptions in that slide of mine. I'm assuming that the average depth is 1.5 meters. So, you know, that's an average, and no one has done, you know, a full assessment of, you know, Eastern Georgian Bay's watersheds, wetlands, and you know, that's hopefully that will get done, but that's a study perhaps for their Nature Smart Climate Change Solutions Fund. But I'm not initiating that because we have our hands full at our land trust.
okay. Janet's wondering, how do we go about preserving our local wetlands?
Well, one of the ways to preserve our wetlands is to create buffer zones around them, so you don't get shoreline development right next to them. That's one of the best ways to do that. Certainly not allow roads to bisect them, and don't allow development that, again, you know, if you remember back to that slide I showed about the connectivity of wetlands, when I was talking about them being a kidney, when you start fragmenting them, they really become vulnerable and they're not protected. So there are systems, and you have to look at them as systems. So keeping that connectivity is a way to conserve them, and creating buffer areas around them is another way to conserve them.
Okay. There's two questions here from Pamela. First, does freshwater store carbon like oceans? And then, is the western side of Georgian Bay in as good health as the eastern side of the bay?
Western versus eastern, I would say eastern is in better shape. And so saltwater carbon storage is called blue carbon. And, you know, the world went crazy about saltwater carbon storage a few years back, because it was found that, you know, saltwater carbon storage doesn't release methane. Well, that's very true. But when you look at the efficiency of inland wetlands, inland freshwater wetlands compared to saltwater wetlands in terms of efficiency, the inland wetlands or freshwater wetlands are far more efficient. You know, they're a large percentage of our landmass. So they're both important, but the percentage of methane released by inland wetlands, especially as they age over time, you remember that slide I showed you of the methane plateauing out, they got a bad rap with respect to methane for no good reason.
Okay. Caroline's wondering if you could show again the slide with the different rates for different types of wetlands. Do you have that at your fingertips?
Yeah, just to start my screen share again, just a minute.
Okay. We will also be sending around a recording of this to everyone, so if there's something you wanted to revisit, you'll be able to do that.
Can everyone see that?
Yeah.
Is that the slide you wanted?
We'll wait to get confirmation on that. In the meantime, Bill, will composting in cottage country make a difference?
Well, it's not going to make a difference probably in cottage country because the density, urban, the low density, but I mean, it's a good thing to do, because if over decades that does add up. Doesn't add up to these numbers, but it does add up, so it's helpful.
Okay, Great. Linda's wondering how the Georgian Bay Land Trust can combine forces with the Georgian Bay
Well,
biosphere.
I might add that just, that composting, proper composting is a good thing. So remember, you go back to that anaerobic, you really, if you're properly composting, I mean, the best way to compost is probably, if it's not, if there are no pollutants in your compost, is to put it in a swamp. Get it underwater. So, sorry.
Okay. Yeah, so that question was, how can the Land Trust combine forces working with the Georgian Bay biosphere?
Well, we already are with our CNPP grant. And they're going to be briefed on this. And I think all of us have Nature Smart Climate. I'm going to be meeting next week or the week after. I have monthly meetings with the biosphere and the First Nations that are involved in the CNPP grant. And we're all going to be discussing what we're doing in this grant stream. What we've already told each other what we're submitting. And hopefully we'll all get a grant. We'll see. And certainly, even this project marries with our existing federal grant, the CNPP grant, with the biosphere. So some of that securement work is marrying into that anyway. So we're already working on this with the biosphere. In short, hopefully, if this grant comes through, we'll accelerate that working. And we have, basically knowledge sharing meetings once a month.
Bill, could you expand on what the CNPP grant is?
It's the Community Nominated Priority Places Grant. It's $1.9 million over 4 years, which was granted to 4 co-applicants, but the Georgian Bay Biosphere is the lead applicant.
Okay, great. We've got some good ideas here from Dale in the comments about wetland protection. He says, read official plans to see what policies are in place to protect wetlands, push for the evaluation of complexes using the Ontario Wetland Evaluation System and get them recognized in official plans. Read the fill bylaw if there is one, as that is a good way to prevent filling if it is properly drafted, and ensure that the official plan and bylaws are enforced. So great ideas, thanks. And okay, question from Ian. What percentage of the inland wetlands would be Crown versus private lands?
Well, I didn't get to that on, I could turn on my GIS and calculate it for you now, but I don't have that figure. I cannot tell you, and I would not be wanting to guess on that.
Okay. Any other questions? That's all that we've got in the chat right now. All right, well, thank you so much, Bill. It was a very informative presentation. And as I mentioned, we'll be sending around a recording of that to everyone. So if you wanted to revisit any aspects of that, you'll be able to. Just a reminder to everyone joining us that our next LandMark speaker event is on March 24th, and that will be Brennan Goose. He was a winner of the Georgian Bay Land Trust King Family Bursary in 2020, and he's going to be sharing with us his research that he did for his master's thesis on landscape architecture, which focuses on a waterfront revitalization strategy for Parry Sound's post-industrial southern waterfront. And you can register for that at gblt.org/landmark. So we hope to see you then. And thanks so much for joining us. Have a great night, everyone.